Hello and welcome to this paper solution for the Math AASL paper for paper 1, time zone 2. I have not attempted this paper before, but let's get started here. It should be pretty simple. Alright, so the first question I'm going to do here is this question. So this question here is they want us to find the perimeter of the shaded sector, the angle theta, and the area of the shaded sector here. To find the perimeter, they have given us the length of the arc PQR, and we know that the radius here is 4, so the perimeter will just be 10 plus 4 plus 4, which is the same as 18. Alright, part B, the angle theta. The angle theta in this case will just be, well, we know that the arc length is theta r, and this is equal to 10, and we know that r is 4, so 4 theta equals 10. So theta equals 2.5 radians. Alright, finally, part C, the area of the shaded sector will just be half theta r squared, which is equal to half times 2.5, or we'll write this as 5 over 2 for now, times 4 squared, which is 16. So it's just 16 times 5 over 4, which is 80 over 4, which is 20. Alright, that's it for question 1. Moving on to question 2. Alright, so this next part here, question 2. Consider an arithmetic sequence that u1 equals 0.6 and u4 equals 0.15. Find the common difference d. So we know that u of n is n minus 1 d in an arithmetic sequence, and for u1, my apologies, u1 plus n minus 1d. So u4 is just going to be u1, which is 0.6 plus 4 minus 1d, and we know that u4 is given as 0.15 plus 3d. Then 0.15 minus 0.6, you just get 3d equals minus 0.45. So this is because you subtract from both sides, and simplifying, you just get d equals minus 0.15. That's simple. Then here, this is a bit more, tiny bit more complicated, but there's a probability distribution of a discrete random variable x such that p x equals n is the nth term of u over k for 1 less than or equal to n less than or equal to 4, and k is part of real positive numbers. So to find the value of k, we actually know that this sum here will, all of these values will sum to 1 because it's a probability distribution. So, and to first we need to figure out u2 and u3, so we can just do, let me just do this here. B u2 equals 0.6 plus 2 minus 1 minus 0.15, which is equal to 0.6 minus 0.15 equals 0.45. Actually, we can just like count it because it takes time to substitute in the formulas. So 0.6, this should be 0.45, this should just be 0.3. Alright, and here, so we just get that 0.6 over k plus 0.45 over k plus 0.3 over k plus 0.15 over k. This is equal to 1. So we just get, sum these values up, we just get, so this becomes 0.6, these two 0.45 and 0.15, so 0.6 plus 0.6 is 1.2, so we just get 1.5 over k equals 1, so k equals 1.5. Alright. Alright, next part here we have question 3. The graph of y equals f of x has a vertical asymptote and a horizontal asymptote. Write down the equation of the vertical and horizontal asymptotes and the y and x and y intercepts. So the first step here is that we know that there's a vertical asymptote when the denominator of this rational function is 0. And it's not given as a direct rational function because you have to actually put this 1 and give it a common denominator. So we can just do rewrite this 1 as x minus 2 over x minus 2. So we just get x minus 2 over x minus 2 minus 1 over x minus 2, and this was f of x. Apologies for this mess. But so we just get f of x equals x minus 2 minus 1, so we just get x minus 3 over x minus 2. And it's pretty clear that the x minus 2 is 0 when x equals 2. So this is the vertical asymptote. And they want us to find the equation, so it's, yeah, x equals 2. So part 2 is the horizontal asymptote, and here you can just look at what happens when this goes to infinity. So this is a bit more complicated, but x goes to infinity of this function here, so x minus 3 over x minus 2. And what you can do, you can apply L'Hopital's rule to solve this limit here, but a simpler way is just to divide everything by x. So we just get equals limit as x goes to infinity of 1 minus 3 over x, and then we have just 1 minus 2 over x. So this just becomes, as x goes to infinity, 3 over x and 2 over x will tend to 0, so we just get 1. So the equation is y equals 1. Okay, perfect. So the next step here, they want us to find the y and x axis. So the y axis will be, when it intercepts the y axis, x will be 0. So we just have to sub in 0. So we just get 0 minus 3 over 0 minus 2 equals, well, the minuses cancel out, 3 over minus 2, this just becomes 3 halves. So the coordinates here will just be 0, comma 3 over 2. The second part, we equate this to 0, so x minus 3 over x minus 2 is 0, because this is when, if we wanted to intercept the x-axis, it's going to be when the y level is 0. So we just get, we set this here, and the only way this will be 0 is if the numerator here is 0, because we can multiply this out. So we just get x minus 3 equals 0, so x equals 3, and we know, and they want the coordinates of this point. Remember, this is a common mistake. Do not put just this x coordinate here. Make sure to give the full coordinates. So we just get 3, 0. Perfect. And now they want us to sketch this graph. And the way you do this is they basically want to sketch the intercepts and the asymptotes. So the first step is that we know that there's a vertical asymptote when x equals 2. So this will just be something like, my apologies, It's a dotted line, like so. Then we know there's a horizontal asymptote at x equals 1. So we just go like this. Y equals 1, my apologies. Okay, x equals 2. Perfect. So now we've done this, we can actually go ahead and write this, the function here, which is going to be 1 minus 1 over x minus 2. Okay, and we know that it passes through these 2 points, so 0, 3 over 2. So 0, 3 over 2 is going to be about, it's going to be right there. And 3 comma 0, so the function will look something like this. And you want it to kind of curve up. I would recommend just drawing this with the pencil first in the actual exam, just so you don't mess up, as it's kind of important. Alright, something like that. Good enough. Alright, probability question. This is pretty simple. So we know that P of A is 0.4 and P of A given B, or conditional probability, is 0.25. And we actually want to write this out as the formula, which is P of A and B all over PB. And we know that this is 0.25. And in the end, they want us to find PB, so let's keep that in mind. And PA union B is 0.55, so PA union B is 0.55. Okay, so this right here can also be written as PA plus PB minus PA and B. Okay, so now we have two variables that have actually been given here, and we need to find one of them. So the two variables here are P of A intersection B and P of B, and we need to find P of B. And we can actually do this with system of equations, but basically, since we know that P of A is 0.4, this becomes super easy. So here we have that P of A intersection B is 0.25. Okay, we'll rewrite this as PA intersection B is 0.25 PB, multiplying it out. And here we can write that we can actually substitute in this value in this equation here. So we'll subtract P of A from both sides, so we just get P of B minus 0.25 P of B, because we have this. P of A intersection B is the same as this. And since we subtracted 0.4 P of A from both sides, this gets crossed out, and we just get equals 0.15. So 0.75 P of B equals 0.15, or actually we can write this as as 3 over 4, so it's easier for us. Oops. Okay, sorry. 3 by 4 PB is 0.15. So 3 P of B is 0. This times 4 is a 0.6. So P of B will just be 0.2. Perfect. This right here is going to be an integration question, and it's not a standard where you just integrate the function here and you can just sub in the values. It's a bit, they give you the area, the value of the definite integral over these bounds, and you have to find the bound C. So what you want to do here is rewrite this so it's 6 marks. So you want to say that the integral from 0 to C of this function, so basically this function here and this the area R, and is bounded by the curve, the x-axis, and this line right here, and they tell you this region is natural log of 3. So yep, so first we can just go ahead and integrate this function, then we'll solve for C later. So we know that x over x plus x squared plus 2 is the function dx equals ln 3. So the obvious step to integrate this function here is substitution for x squared plus 2 is the u value, so we can just do u equals x squared plus 2, and then dx or du equals 2x dx, and we just get half of du is x dx. So we just get, this is the integral, and subbing in here, u equals, for the bounds, u equals c squared plus 2 becomes the upper bound, and if we're substituting 0, we just get u equals 2. Now, the reason I wrote it as half du equals x dx is because then we just know that there's an x dx, so this just becomes our du, and we have the 1 over u here, and then we can rewrite the half outside as a constant. So this just becomes that, okay, so this becomes half, and the integrating 1 over u, we just get, well, the natural log of u, so ln, and we don't have to write the absolute value here because c squared plus 2 and 2 are both positive. So we just get u between c squared plus 2 and 2 is equal to natural log of 3. Now this is an equation where we can actually solve for c, because we can sub in these values and to get an integral evaluated over these bounds. So we just get half ln c squared plus 2 minus half ln 2 is on 3. So now we can just do, we can factor, actually we can rewrite this as 1 log here. So half natural log of c squared plus 2, and then since it's a minus, using the property of the logarithm, we can just write it as over 2 is equal to log 3. And here we can just move the half inside of the logarithm to match out the logarithm, and then we can just cancel it by raising to the e power. So c squared plus 2 over 2, this just becomes a root, is equal to 3, and we just cancel out the ln's, so we just get root c squared plus 2 over 2 equals 3. Square both sides, we get c squared plus 2 over 2 equals 9, c squared plus 2 equals 18, c squared is 16, and let's move this here, and we typically, the solutions, there'd be 2 solutions for this, but from this graph we already know that c is strictly positive, so we can just say that the value of c equals 4 and make a note, c is not equal to -4 because c is greater than 0. Perfect. It's a pretty simple question. So this question right here, question 6, is a composite functions question. And they want us to find two possible functions such that g of f of x is equal to this function right here. So the first thing we'll do is find this composite function g of f of x, which will just be, well, ax plus b squared. I'll write this down here, g of f squared plus ax plus b plus 3. And we can equate this to 4x squared minus 14x plus 15 already. And we can expand here, so a squared x squared plus 2abx plus b squared plus ax plus b plus 3 equals 4x squared minus 14x plus 15. So now we can actually, the way to find out what the values of a and b are by matching the coefficients of the terms. And so we can just group this here. I'll put this x squared term in red. This is the x squared term. I'll put the x term in blue. So this is the next term here, and this is also next term here. And I'll put the constant term in green. So this is a part of the constant, this is part of the constant, and right here as well. Now what we can notice is that since a squared is equal to 4, so this means right here that because we match the coefficient and there's only these two x squared terms, so a squared equals 4 by this. So a is equal to plus minus 4, and now we can see where we get two possible functions from, because it's plus minus 2. And so we also know that 2abx, or 2ab plus a, by grouping these terms, is equal to minus 14. So we'll say case a equals 2, then 2 times b plus 2 is negative 14. And we have then 4b equals minus 16 and b equals minus 4. Perfect. And then this is the case where a is equal to 2, or case where a is equal to negative 2. We have minus 2 times minus 2 times b minus 2 is equal to minus 14. So minus 4b is equal to add 2 to both sides. That's 12. B is equal to 3 when a is equal to minus 2. And they actually want the functions here such that this is true, and we know that f of x is in the form ax plus b. So f of x equals, take the first case, minus 2x plus 3, or 2x minus 4. That's it for question 6. Alright, so the following diagram shows the part of the graph of a quadratic function f. The vertex of the parabola is minus 2, minus 5, and the y-intercept is at point P. Write down the equation of the axis of symmetry. So the axis of symmetry will just be where the vertex is in this case, because it's a symmetric function. And this will just be at x equals negative 2. For this here, did they give us the function here? Okay, actually no, never mind. We don't need this. Okay. Yes, so since the vertex is since the vertex is at minus 2, this will just be x plus 2 squared And then to find this constant k, we know that the vertex is typically at 0. So this will just be minus 5. So h is just going to be, because they want minus h will just be minus 2, and k just be minus 5. And the y coordinate of p, we can solve 1/4 x squared plus 4x plus 4 minus 5. Yes. And then we set this we sub in 0 actually. For x equals 0, that implies that 1/4 of 0 plus 0 plus 4 minus 5. Okay, so, and then we just, which is 1/4 of 4, which is just 1, minus 5, which is minus 4. And they want the y coordinate only, so we just need this value, so it's minus 4. Perfect. Right here we have another function. This is an intersection here. Find the equation of the line L in the form y equals ax plus b. So it's normal to the graph of f at point P. So I'm guessing, yeah, they're referring to this here. So if it's normal to the graph of f at point P, and the y coordinate of point P is minus 4 and this is 0, we need to actually find the derivative of this graph, and then to get the normal, we need to just get the negative reciprocal of that and evaluate it at this point right here. Yep, okay, that should be, yeah, okay. So d, we'll just do it here. 1/4 x plus 2 squared. Yes. Minus 5 f of x. So f prime of x will just be, using the power rule, bring this down. So the 2 goes down, and we don't need to use a chain rule because the derivative of x plus 2 is the same as the derivative of x. So this just becomes a half x plus 2. Perfect. So this is our derivative, and to get the normal, it's just going to be the negative reciprocal of this. Or, sorry, my apologies. So half of 0, we want to evaluate this as 0. F prime of 0 is just going to be a half of 2, which is just 1. Perfect. So normal will just be negative 1 over 1, which is negative 1. And now we know that it passes through, so y of n, we can just write this as normal here, is the same as negative x plus c. And we know it passes through this point, negative 4, 0, so minus 4 equals c. Okay, so y is equal to negative x minus 4. Now we can actually equate this function to find this point q, and we can calculate the distance between the 2 points. Okay, so 1/4 x plus 2 squared minus 5 equals, and we equated x minus 4. It's actually better to expand in this case. 1/4 x squared plus x plus 1. Because we're dividing by 4 everywhere, is equal to x minus 4. Or minus x minus 4, my apologies. Okay, so, and we can multiply Or, yep, so 1/4 x squared plus 2x plus 1 minus 5 minus 4, and then there's minus 4 on both sides, so we can cancel it out, and we just get x 1/4 x plus 2 equals 0. So we know that it intersects one side, x equals 0 already, so we want this solution. So x of q is yes, so 1/4 x of q is going to be minus 2. So x of q multiplying by 4 on both sides, we just get minus 8. Perfect. And now we have this sort of right triangle situation where we can calculate the distance here. And you could technically use a distance formula. I'm just going to show how it works. So this right here will be the height. So minus 8. If we sub in minus 8 to this function, we just get 2 minus 8 minus 6. So 1/4 of 36 is 9 minus 5, which is 4. So f of this point of q is going to be 4. So this vertical distance is 4, and then this is also 4, so this is going to be 8 on this side. And on the top, we know this is going to be 8 here as well. So this d is just going to be root of 8 squared plus 8 squared by the Pythagorean theorem, which is root of 128. And you can actually simplify this down as root 4 times root, or actually this can just be root 16 times root 8, I believe, yes. So this just becomes 4, and then this is 2 root 2, so this just becomes 8 root 2 is the distance between these 2 points. Perfect. Alright, so for question 8, they ask, consider an acute angle theta such that cosine theta is 2/3. Find the value of sine theta and sine 2 theta. Then they want us to show some identities for this triangle here and solve in this triangle here. So right here we have a, for a part I, we'll do it here. Sine theta, we can consider a triangle here where the hypotenuse is 3, the adjacent is 2, and cosine theta is adjacent over hypotenuse. So sine theta is just going to be by the Pythagorean identity. 3 squared minus 2 squared equals root 5. This is the opposite side. So sine theta is just going to be root 5 over 3. Alright, sine of 2 theta is going to be 2 sine theta cosine theta by the identity, which is the same as 2 root 5 over 3. And then 2/3. So this is equal to 4 root 5 over 9. Yes? And we have here showed that b equals 3a over 4. Now we know the values of sine theta and sine 2 theta, and by using the sine rule we can say that sine theta over b is the same as sine 2 theta over a. So root 5 over 3b is the same as 4 root 5 over 9a. Now we can actually simplify it by, we can divide both sides of the equation by root 5 over 3. So 1 over b is equal to 4 over 3a. And then we can reciprocate both sides to get 4b equals 3a over 4. Alright, page 2. So they've said that the triangle is extended here, and then this is an isosceles triangle. So we have this angle theta here. This is going to be pi minus 2 theta, because it's 180 and then minus 2 theta. So the first question here is find the value of sine CAD, or this pi minus 2 theta. And by the identity on the unit circle, we actually know that the sine of pi minus anything is just the sine of anything. So we can write this down as sine pi minus 2 theta equals sine of theta. And so or sine of 2 theta, and which is, we already know that that's equal to 4 root 5 over 9 from earlier. Now find the area of triangle DAC in terms of A. And I'm assuming they made us find the sine of this angle because we can apply the formula half AB sine C. And since it's an isosceles triangle, we know that these two sides are the same. So we can just apply, we can say that this is equal to half, and they want it in terms of A, so we know that B equals 3 over 4. And the second side is also 3A over 4. And the sine C is just 4 root 5 over 9. These 4's cancel, so we get on the top we get 9a squared root 5 over 2 times 4 times 9, so 8 times 9, and we can just cancel the 9, so we just get a square root 5 over 8. And that's it for this question. Alright, so the final question here for paper 1 is this triangle. Oops. Okay, or this circle, and with an inscribed triangle, or yes. So for point Q, show that y equals root 9 minus x squared. So let's go over this question real quick. It's a circle function, x squared plus y squared equals 9, and then we just have center 0, 0, radius 3, and there's these 3 points that have where this triangle has its vertices at minus 3, 0, x, y, and x minus y, or x comma minus y, my bad. So the first step to solving this here, wait, let me see, can I add a new page here somehow? Nope, I don't think I can. Okay, I'll create a new one. But in this case, so we just have A show that y equals root 9 minus x squared. So x squared plus y squared equals 9. And we know that x and y are both positive for Q here, as seen here. So we can just do solve for y here, 9 minus x squared. And typically the function would be a plus minus root something, but in this case we just have the positive value, so y equals root of 9 minus x squared. Alright, that's very simple. So find an expression for A, the area of triangle PQR in terms of x. Alright, this is actually an isosceles triangle. But we actually have the base and height, so it won't really matter. Okay, so B, the A is just going to be half base times height. And if you look here, the base is this value here, which is, well, this is y, and this is also y if you take the absolute value. So half of 2y, and that cancels out nicely later with the half. And then the height of the triangle is going to be some x plus 3, because we take the absolute value, so we take the distance. So times x plus 3 is the area. And we know that y from earlier is root 9 minus x squared. So a half x, let's cancel the half already. So we just get root x plus 3 root 9 minus x squared. Alright, now we can actually differentiate this function to show that dA dx is 9 minus 3x squared or whatever. Okay, so dA dx, we have to use the product rule here. So we differentiate the first function. Okay, so that's just going to be 1 times this function here. And then we have this second function. This is the derivative of the first function, 1 times the second function here, root 9 minus x squared. And then we take the derivative of this, which is something over 2 root 9 minus x squared. And the derivative of the inside of the function by the chain rule is just going to be negative 2x because of the x squared, and then we multiply it with the original, with the first function. So this just becomes, we can rewrite this as 9 minus x squared over root 9 minus x squared, this first part right here, and then plus minus 2x, x plus 3 over 2 root 9 minus x squared. And we can cancel out the 2's here. So we just get, and we can expand this as well, plus minus x squared minus 3x all over root, let's see if that's what we were supposed to get. Yes, okay. 9 minus x squared. Or if we add the functions together here, we just get minus 2x squared minus 3x plus 9 all over the root of 9 minus x squared. And that is indeed what we were supposed to get here, but they've just rearranged it in this way. But so now that we have this value here, we'll actually need this in the next step, D. Hence or otherwise find the y coordinate of R such that A is a maximum. Okay, so part D here, we'll just do it over here. To get it so that it's a maximum, this is going to be sort of a rational function, I think. But basically, we just set this equal to 0. And then, if there's multiple values for where if there's multiple critical points, then we can, to get the maximum, we can just set it equal to we can do a second derivative test, my apologies. Here we can just, we don't have the graph of the area, but we don't need that either. So we can just set this equal to 0. And for this equal to 0, for this to be equal to 0, it's just this top part that this numerator that will be equal to 0. So minus 2x squared minus 3x plus 9 equals 0. This is a quadratic equation. You can solve it like this. Can we factor it? 9 and or minus 18 sum to minus 3. Yeah, we can do minus 3 and 6. So minus 2x squared plus 3x minus 6x plus 9 equals 0. Factor this. minus 2x. I'll group these two actually. So x minus 3 plus 3x. Okay, so plus 3, x plus 3 equals 0. This is factoring quadratic. So 3 minus 2x is one of the factors, and x, or wait, that is not right, my bad. Minus 2x squared is x plus 3. Yep. Alright, and then we just have plus 3x, these two factors here. Plus 3 equals 0. So 3 minus 2x, x plus 3. Perfect. And this will just give minus 2x plus 3 equals 0. Let me reduce this right here. This will give x equals minus 3. And we actually know the maximum area. We actually don't know if the maximum area will be in either one of these. So 2x, this will just give x equals 3 over 2. So we can do the second derivative test. And the second derivative is less than 0. We know it's a maximum for a specific critical point. So the second derivative of this function right here is minus 4x by the power rule minus 3. And we want this to be less than 0. For x equals 3 over 2, minus 4, 3 over 2, minus 3. We get that this is equal to minus 6 minus 3 equals minus 9. So this does indeed say that it's a maximum, so we'll just take this value. And plus, anyway, if it was a negative value here, if, for example, we took minus 3, this would just result in being 12 minus 3, which would be a positive value, or for a minimum. So this is our x-coordinate, 3 over 2. And we know they want us here to find the y-coordinate of r. The y-coordinate of r such that a is a maximum. And to get this, we can just substitute in x, and this is in the negative quadrant, so we just have to do y equals negative root. Now, I'm sorry if I'm not explaining that much, but basically it's negative because to get a negative value of a square root, you have to put a negative sign. Typically, it could be plus minus. For point Q, it was positive. For point R, it's going to be minus, because I've said so here for point R. So y equals negative the root of 9 minus 3 over 2 squared, because we found out it was square root of, if it was 3 over 2, or negative root 9, we'll write this as 36 over 4 minus 9, or negative 27 over 4, or negative root 27 over 2. This is the y-coordinate of r, and that is the ASL paper here. I'm not sure if I missed something. This was my first attempt, so please do mind that. Sorry for the occasional pauses. This is my first time trying this out, but thank you for watching. Hope this helps someone out there.